Hydraulics and Water Resource Engineering Department. The course name is Engineering Hydrology, and the course code Hinge 3123 for third year Hydraulic and Water Resource Engineers. Now, in Chapter 1, Rainfall Runoff Relationship or Application of Different Rainfall Runoff Models. Before to see this different application of rainfall runoff models should be known or a definition of runoff. Runoff is a portion of precipitation which appears in the surface of streams, either very permeable or intermediate nature. This is a flow. This is a flow collected from a drainage basin and appearing as the outlet of the streams. So this catchment, simply runoff is the contribution of drainage basin that generates runoff to the outlet of target point. It is the precipitation excess after meeting the abstraction losses that expressed by in volume or in unit per unit time or common unit meter cubed per second. It may be feet cubed per second, or it may be expressed by dubs in inch, or it may be in centimeter, or it may be in millimeter. So this is said to be runoff. Runoff, it may be different components. It may be surface runoff, it may be subsurface runoff, or it may be groundwater flow. So those are the sum of this component of runoff said to be total runoff or simply runoff. Now, hydraulic models. What are hydrological models? Simply, hydrological model, it is a simplification of a real-world system, that aids to understand the predicting and managing of water source. This is said to be hydrological modeling. Surface runoff modeling, or it may be soil water modeling, or it may be land modeling, or it may be groundwater modeling or choice. So the approximation of a complexity reality using a simple concept is said to be hydrological modeling. Now, there are two types of hydrological modeling: deterministic and stochastic modeling. Let us do it one by one. So, hydrological modeling means it is input, and in this it is an output. There is the input, and there is a process that is a function of randomness, space, and time. So after the processing of this function, we get output. So this system or this modeling is classified into two: deterministic and stochastic hydrology. So in deterministic, there are three types: empirical or Lambert conceptual, distributed model. It is empirical, it is another name, it is black box, it is green box, and it is white box. And stochastic, it is space depending or space independent, and space correlated or space dependent. So there are a lot of parameters that used to determine the hydrologic modeling. So the deterministic hydrological modeling, it is a deterministic model. It is a mathematical model in which output are precisely determined using a known relationship among states and events without random variables. So in this model, there is no a consideration of random variables. The output, simply, for example, you can take rainfall runoff modeling. So rainfall is an input and runoff is an output. So this modeling can be determined by using the known inputs of rainfall and any other parameters that considered in the given model. Deterministic models permit only one output from a simulation with one set of input and parameter values. It only provides one output. It does not make allowance of error. It is not considered errors. So it is considered as no error. This relationship allows one to make prediction and see how one variable affects the others. In this models can show how one variable can affect the output or the prediction. It is one that hypothesizes an exact relationship between variables. Maybe the relationship between rainfall and runoff. It is exact that relationship. There are three main groups of deterministic models: empirical models or black box, Lambert conceptual models or gray box, distributed models or white boxes. Empirical or black box models. Black box models are empirical, involving mathematical equations that have been assessed not from the physical process in the catchment, but from the analysis of concrete input and output time series. For example, it is a rational formula. We can a rational formula. It is equal to the runoff can be expressed by using area and intensity of rainfall, and to compromise maybe to correlate the function by using discharge coefficients, and it's also in hydrograph. It is also the empirical or black box model. They are statistically based and not identify and simulate the process involved. It is only statistically dependent, but it cannot be simulate the process that involved in each process. Second one is Lambert conceptual model. Lambert conceptual model treats the catchment as a single unit. Yeah, it is considered a catchment a single unit. It cannot divide the catchment into subdivisions. We state variables and that represent average values over the catchment area, such as storage in the saturated zone. It may be runoff from that generated from a given catchment area. So it may be in that given catchment area there is a variation of intensity of rainfall, but these Lambert conceptual models can be considered as a single unit, but not divided based on different characteristics. So it is Lambert conceptual model. Due to the Lambert description, the description of a horological process cannot be based directly on the equations that are supposed to be valid for the individual soil columns. The equations are semi-empirical, but still they are physical basis. But these Lambert conceptual models are physical based, but cannot be divide the catchment area that based on different characteristics. So this is Lambert. Distributed models, it is the third types of hydrological model. Another approach to hydrological process modeling was attempted to produce models based on governing equation, describing all surface and subsurface flow process in the catchment. So, distributed models of these types have possibility of defining parameter values for every element in the solution mesh. So, in this model, the catchment area can be divided into catchment area based on different hydrological or meteorological characteristics, or it may be land use and land covers, or it may be soil characteristics, or it may be any other parameters that used to model the rainfall runoff relationship or any other relationship. It may be storage and inflow and outflow and storage relationship, whatever that we wanted to model the system that we wanted to model. So the catchment areas can divide into subdivides. They give a detailed and potentially more correct description of the hydrological process in the catchment than do the other two models. Stochastic time series model, it is the second type of hydrological model. In the stochastic model, the chance of occurrence of the variable is considered twice, introducing concept of probability. This is in this stochastic or time series hydrological model, or probability hydrological model. In this, the probability of the occurrence of an event should be considered. Stochastic models allow for some randomness or uncertainty in the possible outcomes due to uncertainty in inputs, variables, boundary condition, or model parameters. So this is considered uncertainty or the lowness of errors. Method of runoff computation. There are a lot of method of runoff computation. So let us see one by one. Determination of accurate runoff rate. Determination of accurate runoff rate or volume from the watershed is a difficult task because runoff depends upon several factors related to watershed and atmosphere, and prediction of which is not so easy. It may be runoff depends on physiographical factors, or it maybe depends on rainfall or precipitation factors, or it maybe depends on topographical factors or human factors. So those factors cannot be modeled easily. So the determination of the accurate runoff are to become difficult. Due to this reason, the complexity of rainfall runoff modeling is more complex. So, however, some common runoff estimation methods are given below: rainfall runoff correlation, empirical methods, rational methods, infiltration index method, and soil conservation service curve number method, and hydrograph methods. So those are some methods that is used to determine rainfall runoff relationship. Now, the first one, rainfall runoff correlation. Better method is to fit the linear regression line between runoff and precipitation, and to accept the result if the correlation coefficient is near to unity. If the relation coefficient between rainfall and runoff that are near to 1, so there is best correlation between rainfall and runoff. Simply, rainfall regression is the estimation of runoff from a given precipitation by using linear regression line. The equation for straight line regression between runoff and rainfall is R is equal to A times precipitation plus B. A is it is a slope of a straight line, and B is it is y-intercept, and that's the lines R and runoff versus precipitation graph, and the value of the coefficient A and B are given by the equation. By using this equation, we can determine the slope of the graph, and by using this we can determine the slope of the y-intercept of the rainfall versus precipitation graphs. N is the number of observations, that R and P, yeah, and N means the number of observation, and P is a number of or a data set of rainfall data, and R is the runoff data. It's maybe it is a monthly, or it may be daily, or it may be in hourly, or it may be in annually. So we can correlate annually to annually, monthly to monthly, and hourly to hourly, and also daily to daily. So if our developed equation is valid or not, we can check by using this equation. R, it is correlation coefficient. By using this formula, we can determine the R value, and the R value between 0 and 1 always is lies between 0 and 1, and R value is only positive correlation with P. Yeah, if the value of R smaller, not runoff, if the value of coefficient of correlation is between 0.6 and 1, it indicates that good correlation, and also it should be not R greater or equal to 0. If the correlation coefficient are less than 0.6, it is a poor correlation. Yeah, it is a poor correlation. And if the correlations are between 0.8 up to 1, 0.8 and 1, so there is very good correlation between the two parameters. So we can see an example that just go to rainfall and examples how. So it is not our examples, just yeah, it is an examples and how to determine this example by using rainfall runoff correlation, So we can determine this formula. Now a solution table stated in above, and the next one is the percent of dependability, 75% and 50% dependability. Maybe it is already no, number of data is 21 year, and it is the data expressed by centimeter. So by using this table, we can estimate the first one is the required one, required. Okay, required A 75% and 50% dependable rainfall, runoff, annual runoff yield, or annual yield or runoff. Okay, dependable, yeah, it is dependable. So the next in B estimate or develop rainfall and runoff correlation equation. Rainfall runoff correlation equation. So after identify the given value and the what questions are asked, so we can go to solution. Step one, determine, or step one, arrange the given data in descending order. To estimate the probability of the occurrence of an event. Or the occurrence of annual rainfall. There is some errors, it is occurrence, and also there is a space error. So simply to determine what is the errors, grammatical errors, yeah, arrange the given data in descending order. Okay, and enter. So it's good. So to simplify our calculation, just go to Microsoft Excel. Just after opening the Excel and copy the values, this value in Excel, and also copy this formula in the Excel. Okay, paste. Okay, after copy this formula and this given data, so we can write each value here, 1975, 1976, 1977, 1978, 1979, 1980, 1981, 1982, 1983, 1984, 1985, 1986, 1987, 1988, 1989, 1990, okay, 1991, 1992, 1993, sorry, 1994, 1995, 1996, 1997, 1998. Yes, that is the last year. Okay, 95, yeah. Up to 95. Up to 95. Okay, we can delete the two values. So after just next annual rainfall, annual rainfall in centimeter, annual rainfall in centimeter, and just 118, 98, 112, 97, 84, 91, 138, 89, 104, 80, 97, okay, 50. Oh, it is another rainfall. Okay, just annual runoff, runoff 54, 45, 51, 41, 21, 32, 36, 25, 42, 11, 30, 32, I think. Yeah. Then after this 75, 107, 47.5, 93, 129, 153, 92, 84, 111, 95. Yes, already finished. Just drag to write the annual rainfall, I think. Yeah, just move to that. Then 17, 32, 15, 28, 48, 76, 27, 18, 52, 26. I think already finished. So we can delete this value. After see this value, arrange the given value in descending order. It is randomly ordered. Those two columns are randomly ordered, so we can arrange the given value in descending order. Descending order of runoff. Just just first copy this runoff value and copy and just paste. So by using selecting value, I think where is sending order, I think insert. Oh, where is sending order? Yeah, I have to Z filter or yeah, sort from largest to smallest value. Yeah, please continue. Yes. So the two values are arranged in descending order. Not this value is already sent in small to value. Oh, what is the problem? Think undo, cancel undo. Yeah. Oh, sorry. It is already cut. Copy, paste. So these values joined to the previous, randomly. I think undo. Yeah. Wait. And just copy it. Copy. After copying, now value. Oh, I think it is after this arranging largest to smallest value. Yeah, good. It is now arrange the value, a given value in descending order. After arranging this value in descending order, we can estimate. we can give rank is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After this we can drag. Yeah, so this is a rank. After determining the rank, we can estimate the probability of the occurrence of each events for a given year or a given time interval. So the probability P, can denote by P, this is the probability. Then P is equal to M over N plus 1 by using which formula? We pull formula. Then 1 over N is 21. Then we can sum 1, 22. I think it is in percent. So 18% should be multiplied by 100. So it is a percent. Just click. Then it is the probability of the round. I think there is a round. I think it is a round. No, it is a round. Yeah, it's good. After determining the probability or the probability of the occurrence of an event, we can estimate 75% occurrence of annual rainfall and 50% annual rainfall. Just we can go the value. It is 50% annual rainfall. Now this is the value of 50% dependable rainfall dependable rainfall runoff, sorry, runoff is equal to what? It is 5%, 50%. Just the runoff value is 32. There are two values, yeah? There are three values that occurs. So 32. It is, the value is 32. And 75% dependable rainfall. Dependable runoff, sorry. Dependable runoff. Just move to this value. So these values can be occur in this between these two values, yeah, 72.7 and 77. So by using interpolation we can determine 75% of runoff. So this is the value. Just arrange the two value, 25 with 72.7 and this side x side the required one, and 21, and also it is 75%, and it's also 77.3. So by using the interpolation descending order, and we can it is descending order. It's already step 1 is already computed, and just move to step 2. Step 2. Oh, sorry. Step 2. Step 2. Rank and determine the probability of rank, and determine the probability of 50%, right, and determine the probability of the occurrence of annual rainfall, annual runoff, sorry, annual runoff. Just it is stated in as in column I think you can check in Excel in column 1, 2, 3, 4, 5, 6, in column 6, and it is 6, 5 and 6, column 5 and 6 respectively. Okay. Annual rainfall. Okay, respective, there is spelling error. You can check whether it is the correct one. There is spacing. Column 4, check it. Yeah, in descending order, it's column 4. So after determining this value, the A value, A is equal to the 50% dependable rainfall. 50% dependable runoff. No spacing. Runoff is equal to I think 32 centimeter, and the next one is P. The next one is 75% dependable rainfall, dependable rainfall, dependable rainfall, dependable runoff, less between 72.7% and 77.3% from the computer table. So slice light. So this value determined by using this value determined by using interpolation. So there is interpolation equation. Just we can go to insert and just what equation, equation x and y vector equation. Okay, after this write this value. I think can go to this Excel value, 25 x and 21, and x is occurred between 25 and 1, just then x minus 25 over 21 minus 25 or 25 minus 5 can arrange this if you need. It means x minus 25, okay, closed, and over 25 minus 21, so it is in bracket, and just equal to just can also get this formula, and now go to next cell. Then 75 minus 72.7, okay, 75 minus 72.7, okay, and also at bracket 25, 25 is up, 72.7 minus 77.3. I think you can check it. We can check it in this table, in Excel table. This minus this value 75.7. No, it is 3. It is 3, not 7. Okay. Think save it. Okay. Now it is rainfall runoff correlation. You can save it as you want, but I want to save this in engineering hydrology folder. In this folder, it is my code, and just after adjusting in this equation, so we can determine by using calculation or calculator. Then this is just can enter to the equation and just you can bring a formula. Okay, so x minus 25 over what? 4, 25 minus 3 is already 4, and just is equal to just click this and enter this value. The next one is 75. I think I'll reduce by calculator. 75 minus what? 72.2 is equal to 2.8 and over 72.7 minus 77.3 is equal to it is minus 4.6. After this it is equal to, we can reduce again 2.8 divided by 0.6 is equal to 0. Minus 0.6 what? 61. Just we can multiply it by this value, and or again we can take another equation. This value, this is x minus 25, and we can replace this value equal to 4. It's equal to again minus 0.61. Just sorry. Undo. Where is undo? Just it. Okay. Click at the center. It is equal to minus 0.61. It implies that. Okay. Just comma, then insert this value. Simply x minus 25 is equal to by cross times 4 can get 2.3 2.4435. This minus sign. Just after this, x is equal to x. Now just go to formula and write in mathematical equation, in the form of mathematical equation. Then this. Sorry, what is the problem? Okay. This x minus, or x is equal to can sum up minus 25, just 22, and the value is 22 dot what? 56. Can approximate this value. I think it is 54. This is the value. So this is here's the 75% dependable runoff is 22.56 centimeters. Is already computed. After computing the value A, just we can go question B. Question B, develop rainfall and runoff correlation. Save it. Save it. So just go to in Excel and just by then can delete this value. That's this. then we can correlate the correlation coefficient. We can determine the correlation coefficient of rainfall and runoff by using two methods. So by using this formula, we can estimate the correlation coefficient, or we can determine by using Excel. Excel, by plotting annual rainfall versus what? Annual runoff. So we can determine the coefficient. That means the value of A and the value of B, and also the value of R we can estimate. So we can do by using two methods. Sorry. In the first, we can select these two columns. That means the value of annual rainfall and annual runoff, and just insert go to insert, and then click in scatter and select this value or this value. Select this value, so we can get this value. It is what? It is annual rainfall. This is annual rainfall, and this is annual runoff. So then click this value and right click, just add trend line. So there are a number of trend lines. It may be exponential, it may be linear, it may be logarithm, or it may be polynomial, power, and moving average. So in this case, we can select. We want to develop the linear regression line. So we can select this value by default already selected, and add equation. Click in this, and at display R square, we can click closed after this. So this is A means 0.738 minus B means it is minus 4.444. R square is equal to 0.99. Then R is equal to what? Under root of R. Yes, it is equal to sorry, cancel it, and just equal to under root of 0.9001, the power of 0.5. Then this R is equal to what? Simply R is equal to, or the correlation coefficient is equal to 1.5. It is 0.95. It is already near to what? Near to the already near to 1. So it is very good correlation. So it is a value, and A is equal to what? A is equal to 0.794. I think you can approximate or 38, and B is equal to or the intercept y-intercept equal to minus 4.44. So it is a correlation coefficient, and the developed correlation coefficient equation is equal to what? This value. This is the equation. It is coefficient equation. It is the first mechanism. It's just we can go in the word, and we can state in this. So we can estimate the equation by using 2 meters. First one by drawing or by plotting. First one by using Excel. By Microsoft Excel, using soft Excel. So plotting spacing. Plotting annual rainfall versus what? Versus annual runoff. So spacing, annual runoff. So the drawing seems like this. So drawing this as stated in Excel. So we can this Yeah, after getting this value, and go to in layout. So in axis title, yeah, it is horizontal, below, side annual rainfall, in centimeter, in centimeter. So I think you can in capital, and just move to in home and adjust the font size. Okay, it's added, and just click in time Roman. Oh, already the term manual is large, so can advise you 24, I think. No, sorry. So you can select the whole. Not needed. So after this, enter to home and just select. I think it is enough, and just use time Roman. Sorry, and just go to in the ordinate or in the axis. Just click up to 1/8. Okay, and just to move this value, and okay, this is the same as first, and express the font type in time Roman, and after this we can adjust the title, go to this layout and just click this, and it is vertical and horizontal by default axis. Tight. No, it's tight. Yeah, vertical, rotated. Think selected. You can select as you want. Annual runoff, in centimeter. After this, we can just the font type and font size. Okay. Oh, it is good. Can adjust this value, and we can adjust this value. It is R, yeah, and X it is precipitation or rainfall. Then you can this is legend, yeah. This is the equation, yeah, the equation, and R it is by underrooting this value we can get the R square root is the determination coefficient, yeah, it's type to be determination coefficient. Is one mechanism, and the next one is, or the second one, just to go to in Excel, that is by using using the formula, formula we can estimate A and B, and B value, it is not capital, it is letter, yeah, B value by using the formula. Then from this graph, A is equal to small a is equal to what? Oh, I don't need capital. So A is equal to 0.794, I think, approximate, and also B is equal to minus 4.44, and R is equal to under root of this value, it is equal to, I think, 0.95. Still in the Excel. This is so. Hence we can conclude, since the value of value of r near to is equal to 0.95, near to unity. It indicates that there is good or a very good correlation between rainfall and runoff. It is good. Okay. Now, so we can go to an Excel and estimate by using a formula. Just calculate p square, yeah, p square and r square. Then it is equal to p power of, then click or drag, and also it is equal to this square, enter, and just drag it or double click. So we can compute b square and r square, yeah. It is already moved this down. So we can determine the value of this value, and then we can move to down and drag this equation, change this equation. So to determine this value should be, and also sorry, and one parameter already remain, PR. Then the product of the two terms is equal to this value times this value, enter. Oh, sorry, what times means this value, just enter, then double click. Okay, so already computed. Then we can estimate the sum value, summation. I think the sum, I think we can state in sum of this value equal to sum, then double click, drag this value, it is p, sum of p, and we can, I think it is cancel, and we can drag it horizontal and check this value is the sum of runoff. Yeah, it is already the sum of runoff. Okay, after determining this value, there needs the sum of p square. I think it is third column, it is cancelled. Can delete this value and just it is phrase, I think in view, phrase the span first to pro, then can move, yeah. Then this is sum of p square, yeah, equal to sum, and just move to upward until the top, enter. After this we can drag in horizontal, so the required term is already determined, so we can substitute to estimate the value of a. It is these values can be taken from the graph. We can shade by using this color, yes, and the value of r that's estimated from this graph, not first the value of a, it is equal to first the value of a, I think for this column, the value of a in this column, equal to, by using this formula we can estimate by using this formula. Then n is equal to, I think n is equal to T1, then T1 times sorry, times enough in bracket the summation of PR, product of PR, it is summation, then closed in bracket, minus summation of P times, it is times what, summation of R, bracket, then over the overall bracket, over what, over in bracket 21 times what, times summation of P square, summation of P square is value, then minus what, the summation of the whole P square, yeah, summation of P square, then this value, the power of square. It is already, yeah, enter. Oh, yeah, it is good. It is already approximate, yeah. This value is 0.738 and this value is what, 0.7938. It's approximate to 0.9. Oh, it is good. 938. Yes. Oh, after determine this value, we can estimate the y-intercept or p value, b value, sorry. B is equal to the summation of R. What is the summation of R? Summation of R, this is R, yeah, minus A times what? The summation of P. Oh, it's good. And then over what? Before T21, it is n is equal to T21, the number of data set, I think it is, and in bracket, simplify our enter. Yeah, yes, it is exactly the same as to the that determined by the graphical meters. Yeah, yes. So after determining this value, we can estimate the R value. Yeah, the remaining one is the runoff coefficient. Yes, runoff coefficient. It's equal to coefficient of correlation. Sorry, runoff coefficient and the coefficient of correlation is big difference. Yeah, it is big difference. So R is equal to n times 21, and in bracket what? Summation of PR, summation of PR, it is summation of PR, in bracket, minus what? The summation of P, it is summation of P times the summation of runoff, and closed, enclose the bracket, the whole in bracket, then over, I think, over in bracket, again in bracket, it should be care, and the bracket as the whole term, and 21 times what? Times summation of P square, summation of P square, this value, and also minus sum of P the whole square, okay, I think we can close the bracket, and times in bracket 21 what? Times the sum of R square, this value, and minus the square of the sum of R, square of the sum of R, is the power of square. Can check the bracket, enter. Oh, it is, I think it's fault, yeah, should be adjust your bracket before estimating the value, or before entering, and count the number of brackets. Number of brackets. Okay. First to simplify our error, they should be adjust in paper before. Okay. So R is equal to what? R is equal to n sum in bracket summation of PR minus what? Summation of P times summation of P in bracket over under root of it is bracket I think and bracket ያስፈልገኛል n p square minus p the whole square የዚህ ብራኬት ያስፈልገዋል። ያ ማለት ችም ታስፈልጋለች ማለት ነው። ሲባዛ ዋት ሲባዛ n c r square ትንጭ ቅንፋለችው ሲቀነስ cr the whole square then ይሄ ብራኬት እዚህ ጋር አንድ ብራኬት አለ። ትኛው ብራኬት ዘጋውት 1 የተዘጋ ይሄኛውና ይሄ ተዘግቷል። ነገር ግን ማን አለ ይሄኛው ብራኬት አንድ ብራኬት አለኝ። ኦኬ ከዛ አንደር ሩት አለኝ አይደል? ሌላ ሰርድ ብራኬት ይኖረኛል። ሲን አንድ ጋር ብራኬት አለኝ አንድ ብራኬት ጋር ይኖረኛል። and then the power of ነጥብ 5 and ያለኝ then first bracket the counting first c times this value okay minus this value it is okay so now to this bracket how much 2 yeah we can add no before this I think it is cancel then the bracket is out of the power and also we can add another bracket enter. Oh, I'll just make a fault, yeah. So to simplify our equation we can estimate the denominator and numerator separately, yeah. Just simplify should be it is denominator is equal to what n times this value n 21 times what summation of the product is value minus the sum of r times what this value enter. This is the numerator. Denominator is equal to it is numerator and also denominator without bracket denominator okay denominator is equal to what is equal to bracket what 21 times summation of p square this value okay ቅንፍ ዘጋውት ሲቀነስ sum of p square is the whole square okay ይሄ ብራኬት ያስፈልገዋል እሱ አንድ ብራኬት ይጨምራል ማለት ነው። ኦኬ after this times bracket 21 times what r square sum it is r square then minus sum of r square then can close bracket close bracket. After this can shall enter check አየ ቲንግ አንድ ብራኬት ጀምር ያለታል ድንያለኝ ይሄን ያህል ቫልዩ ሆነ ይለኛል። ኦኬ ይሄ ማለት እኮ ምንድነው n summation of p square ማለት ነው አይደል? ዘጋውት times n r square minus summation of r square ማለት ነው። n times p square okay in bracket minus this square okay times 21 times r square minus this square okay enter. So it is equal to bracket okay under root 0.5 enter. So So after this is equal to this value r is equal to yeah, over this value. Yeah, exactly. It is the value. Yeah, thank you. This is already these values and this value already this value and oh, how is that? This value and this value already the same. It is r value. Yeah, it is already r value. It's approximate to what 95. So these values are already what this is r small r capital R, and it is A that is estimated by a equation, and it is B. So the Excel values can be used this formula to estimate with the coefficients. So this is the same value. Can get the same value by using in graphical and also in estimated by equation. This is all the equation that estimated. So you can take this graph, then change it in table form by using this, and also we can adjust this value, and we can adjust time Roman, yeah, time Roman, enter, then copy and just move to what in our targeted area in Word. Yeah, this is what our calculation. So from this table and from this yes, this is a table. Yeah, these tables are I think this is already MBT column. It can release the column. Yeah, just move to this. Oh, sorry, adjust our table. Adjust our table. Adjust and adjust, and also adjust this value. Adjust. Okay. So this is already a table that prepared. There is the developed the correlation equation of R and P, R and P. Sorry, is given as follows: equal to R is equal to 0.79 but 4 times P minus 4.44. It is the correlation coefficient and it is the required one. Yeah, it is the required one. Now this is the problems that already stated. For your attention, thank you everybody. Goodbye.